Hello everyone, and welcome to our first attempt at solving inequalities instead of equations. Okay, an inequality, as opposed to being an equality, is a mathematical sentence that compares quantities. Meaning, this thing is bigger than that thing. Ta-da! Okay. It's just some things to remember because I think you've met inequalities before. There's a greater than, which means the number that's on this side is bigger than the number on that side. There's less than. But basically, we would just remember that whichever side, the open part is open to, it's trying to eat the bigger thing. Hopefully, you remember that. Okay. Then you can have greater than or equal to. Okay, greater than or equal to looks like this. Less than or equal to looks like that. The difference between these two is that the number that's written is included in the answer here. It's not included here. Now, the way that we denote that on a graph is when we're graphing these, if it's just greater than or just less than, you'll put an open dot on the number. If you have or equal to, you put a filled in dot. Okay, and that's because on this one, that number is included. On this one, everything up to that number is included, but not that number. Okay, so there's those two things. Now, here's the good news. Today's lesson should be soups easy. We solve addition and subtraction inequalities exactly the same way we solve equations, okay? So with multiplication and division, there's one thing you have to remember. One thing you have to do different for multiplication and division, but for addition and subtraction, it's all exactly the same. So remember, our goal is still to get the variable alone, or to get to the. Yeah, that just happened. All right, so let's give this a whirl and see what happens. Okay, let's have x plus 3 is greater than 10. X plus 3 is greater than 10. Okay, so here we go. Our goal is to get the variable by itself. Right now, the only thing with it is a plus 3. So to get rid of that, we subtract 3 from both sides, brings the x down. Those turn into 0, so we don't have to write it. Bring this sign down. Now, this is, again, where things get a little sticky on tomorrow's lesson. And then 10 minus 3 is 7. Okay, so x is greater than 7. That means that, but 7 is not included. So 7 doesn't work, but 7.00001 does work. Does that make sense? So everything up into 7. So let's practice graphing, because I love graphing inequalities. It's super fun when you start graphing lines and then the intersection of the inequality, and you get to shade stuff and color things. You might not do that for a year or two, but it brings me happiness and joy. Alrighty, so 0, 1, 2, 3, 4, 5, 6, 7. That's our 7, okay? And do we need an open dot or a filled in dot? It's just greater than, so we're going to put an open dot at 7. And then you need to figure out which direction we're going to shade. And as long as 0's not your actual answer, I love testing with 0 to see if it works, okay? If we put 0 in for x, does it make a true statement? 0 greater than 7? That is not a true statement, so we are not going to shade the side that 0's on. We're going to shade the other side. Okay, because it means literally to infinity, everything up until 7 will make this a true statement. Okay. Another trick you can use for knowing which side to shade on, but you have to be careful. If your variable is on the left side, then you can kind of pretend to turn your sign into an arrow, and it says to shade to the right. Okay, but again, that only works when your variable is on the left side. So let's try one where the variable is not on the left side. We'll have a conversation about this, okay? So we got -6 is greater than or equal to n minus 5. Okay, so you can see that the n is on the right side this time. Only thing with it is a -5. To get rid of that -5, we can add 5 to both sides. And we get -1 is greater than or equal to n. Okay, so if we go straight from there, well, that was a really long number line for needing, -1. It's fine. Okay, so we can think about it in a couple of different ways. Because our variable is on the right side, we can't use our arrow trick unless we want to flip the entire thing, which we can do. But if you flip the entire thing, you have to make sure you flip your inequality as well. So this is the same thing as n is less than or equal to -1. Okay, now as you read it that way, it becomes pretty clear. We're going to have, this is or equal to, so we're going to have a filled in dot at -1. And then if you think about it, n is less than -1. Less than is to the left. Okay, there's that. You can draw the little arrow if that makes you feel better. Any of those things. But if you can just get good at reading these mathematical sentences backwards, then, that works too. All right, so that's kind of the basic idea. We do have some story problems. Well, we have one more, and then I'll get into some story problems. Because, we all love story problems. All right, x minus 6 is less than or equal to 4. X minus 6 is less than or equal to 4. Right now, the only thing with our x is a 6 minus 6, so we're going to add 6. Add 6. X is less than or equal to 10. Okay, and the variable's on the left side, so we can do this thing. Have some numbers. I'm going to call this one 10. Filled in circle at 10. And then if we read it, s is less than or equal to 10. So less than is to the left, or draw the little arrow, and that means we're coloring in that way. Okay, we want to have fun, use colored pencils, whatever, it's good times, right? That's one of the things I love about inequalities, is you can use some colors if you want to. Okay, so now we're going to do a couple of story problems, because I think the hardest part about story problems is translating from story problem to math. So here we go. Dylan has $18 to ride go-karts and play games at the state fair. Suppose the go-karts cost $5.50. Write and solve an inequality to find the most he can spend on games. So assuming he only rides the go-karts once, that means he's going to start out with $18. He's going to spend $5.50. And we need his total. Oh, wait, hang on. Dylan has $18 to go to, that 18 is the total. So however much we can spend on the games minus, plus the $5.50. Oh, I'm doing great today, guys. Winning. Okay, so this, how much we can spend on games is here. That plus the $5.50 needs to be less than or equal to, because he could spend the full $18. So like that. So I apologize, I put it together a little bit wrong, but this is feeling much better. So again, however much he can spend on the games plus what he spent on the go-karts, and that needs to be less than or equal to the $18. Okay, I'm gonna write that on the other paper. And we'll call it G for games here, plus 550, and we need that to be less than or equal to 18. To get a variable alone, we just need to minus 550. See, I was just trying to actually do the math rather than putting it into an equation, which is a temptation for these simple equations. G is less than or equal to, and if we subtract that, $12.50. Yes, $12.50 to play games. Or he could go ride the go-kart again and then have even less to go play games. You know, he gets to choose. Next up, an elevator can hold 2,800 pounds or less. Okay, so we want 2,800 pounds. It can hold that, so we have or equal to, or it can hold less, right? And solve an inequality that describes how much more weight the elevator can hold if it's currently holding that many pounds. So how much weight can we add to 2,375 before the elevator comes crashing down? That's fun and happy. All right, I'm going to write this on my other paper just so that I have more room for solving. So this one, we're going to say the weight that we can add plus 2,375 is less than or equal to 2,800. Okay, so there we go. And then we just need to subtract this one, 2,375, from both sides. Again, this part is pretty easy. There's a complication with the multiplication and division, okay? And so those turn into 0, and we're left with the weight is less than or equal to, and if we subtract those two with the calculator, we are left with 425 pounds. Okay, and there you go. Making equations, solving them, or equations and inequalities. But there you go. It's pretty much exactly the same thing except for graphing. Good luck.